So you please be ready with your notebook and pen. Be ready with your notebook and pen. Okay. So today I am going to discuss about methods that will minimize the expression or that will minimize the hardware. You know that always I am talking about the minimization. As a good designer, as a good engineer, your target is you should design a circuit that occupies less area, that has high speed, and it consumes less power. Okay, so every time I used to say you that as a good designer, your design should be like it should be such that it should occupy less area. Less area means it should implement with the less number of gates, and it should perform high performance means high speed. It should respond so fast, and the power consumption should be as less as possible. So our target will be like this. So now today's topic is related to the simplifying method that are available to minimize the hardware. Okay. So hardware, I'm saying that if suppose you are going to design a circuit, you will realize a physical circuit, physical logic gate circuit. So here there are various methods available. So one by one I will discuss these methods. So let's see what are these methods available. So one by one we will learn. So in today's lecture we will learn one method, and tomorrow or day after tomorrow we will learn rest methods. Okay. So first method is algebraic method. Algebraic method, that means we will use here Boolean functions, Boolean expression. Second method is your Karnaugh map method. So you please note down how many methods are available through which you can minimize your hardware. Second is Karnaugh map method. The Karnaugh map method is a very famous method, and you will love to do the Karnaugh mapping. So once we will discuss this, so I hope that you will find it very interesting. So it is a very simplest method, and it depends on the great extent up to your human intuition, and it is useful up to 6 variables. Though it is the simplest method, but you can use up to 6 variables only. So generally we use manually. We do simplification manually. So two methods generally we do, algebraic and K-map. Karnaugh map, also known as K-map. Another method is Cohen-McCluskey method. So what is Cohen-McCluskey method? We can do manually. But if you want to do the simplification for the larger circuit, it is very useful. So you can do computer mechanization. Another method is variable entered mapping method, the VEM. Okay. So in your course it is not mentioned any method, just K-map is mentioned, but I hope I should tell you the Cohen-McCluskey means little bit. But we will more concentrate on the two method, algebraic method and Karnaugh map method. Okay, if time will permit, then I will go to the Cohen-McCluskey method. So let's start with the algebraic method. So algebraic method, our purpose is to minimize the hardware. So in this method, we will try to do the simplification of the expression. So here, as an input, you will have a Boolean expression, and you will simplify that Boolean expression by applying Boolean theorems. Okay, you already studied Boolean theorems, so you will use those Boolean theorems to simplify the complex algebraic expression. Okay, So once you will get a simplified expression, it will result in a minimized logic circuit. I am repeating, algebraic method is used to get the simplified expression. So you will start with the complex Boolean expression and you will apply Boolean theorem, and as a result you will get a simplified expression that will contain a least literals. Then you will say that it is a minimized expression and it will result in a minimized logic circuit. So while doing the minimization, while simplifying the Boolean expression, you have to take care about something. Like you know that while doing algebraic, uh, if you want to solve the mathematic equation, so you have to remember about the precedence of the operators like plus, multiplication, division. So which one you should take care first? So you have to apply a bod mass. You remember that if you are simplifying an expression, you have to follow the rule called bod mass. So same thing, you have to remember the precedence of the logical operation in the Boolean algebra. Okay, so for simplifying the expression, you will remember the precedence. So which operator will come first, you have to remember it. Okay, so what will be the advantage of minimization? As I said, it will reduce the cost, it will reduce the complexity of the associated circuit. So this is the advantage why we are doing, why we are bothering about the minimization, because this minimization will result in reduction of cost and the complexity. Complexity will reduce, cost will reduce, performance will improve. So what is the precedence you see? So I'm showing you here the table that is showing the operator. So here by symbol I am also showing. So not is the highest precedence and medium and or lowest. So this is the precedence table. So whenever you are solving the expression, you have to see which operator is there. So based on the operator, you will give you will assign the precedence. Based on that operators, you will simplify the equation. So you, as I said, that for minimization you should remember the Boolean theorem. So again I am showing the Boolean theorem we already studied. So you please see it once. See it once. What are the property we are going to use for minimization? As already told you that 3 gates are there. So based on 3 gates, some property are there. So here I am showing 1, 2, 3, 4, 5, 6, 7, 8. 8 properties for and or. So first is your annulment law, and second is your identity property, third is idempotent property, complement property, absorption property, associative law, distributive law, commutative law. So these are the property, and one property is there for not operation. It is called double negation law. Double negation law. So if you are doing AND operation, you can use Boolean AND. So it is also known as conjunction. Boolean OR is also known as disjunction. So you please remember the different words. I'm repeating. Boolean AND is also known as conjunction, and Boolean OR is also known as disjunction. So this word also you please remember. So sometimes you will find this word I'm writing here. Conjunction is actually your Boolean AND. Disjunction is also known as Boolean OR. So these are the laws just I am showing you here, because for solving the problem, for simplifying the expression, we will use this law. So you please remember some. So hope you remember. So these law we will use to simplify the expression. So for how to reduce, how to minimize the expression, I am taking some examples. So you please listen carefully, and then I will ask you, once I will explain, then I will ask you to solve one or two examples. Okay. So this is the example here. I am showing the function. So input is the given thing here is your Boolean expression, and that Boolean expression contains three variable x, y, z. Now you want to minimize. So what are the steps to minimize is, first of all, you will see any term is repeating or not. So you will see whether any term is repeated or not. So you first to identify if any term is repeated or not. Then you will apply a theorem. If suppose any term is repeated, as this is a SOP form, so any term is repeated, that means you will apply a theorem called idempotent. What idempotent say? A plus A is equal to A. Means if A is repeating twice, you can write it once. Okay. So first of all, you will identify any term is repeated or not. So if you are talking about the SOP, then you will use this theorem. If you are dealing with the POS form, then you will use this theorem. Okay, so based on the type of the expression, you will use the property. Understand? So this expression is your SOP form. This expression is your SOP form. So if any term is repeated, so you will apply this property. Okay, idempotent property you will apply to write a repeated term as a single term. Got it? Now, first, now I want to simplify it. So I will see any term is common here. Any term is common here. So I want to absorb the terms. So absorption can be done if we combine the expression. Okay. So you see here any term is common here. How can I reduce? Just you see. You already did the algebra in the mathematics. You see. So you see here that this x bar and this z. This x bar and this z is common. Okay. So what I will do, I will first take common. So if you go to if you realize the hardware, you will get this. So I am showing the hardware also. After realization, this function, you will get this hardware. My target here is to explain you how to minimize. Okay. So the effect will be in the number of gates. You will see later. So here we are using total number of 6 gates, 5, 4, 5, 6 gates. So let's see how many gates we can minimize. So first what I am doing here, I am taking common x complement z, and in bracket I have y plus y bar. Okay. So y plus y bar, you know the property, what I said, y plus y bar, what is the property you can use here to reduce this y plus y bar? One property I told you, y plus y bar is equal to, you know, what is y plus y bar? It is 1. And this property is called complement property. So that complement property I will use here to replace the y plus y bar term with 1. So I am using this property. So I am replacing y plus y bar with 1. So you will get this. Okay. And next property, you know that another property you will use here, that is a dot 1 is equal to a. A and 1 equal to a. It is called identity property. Another property you will use, that is called identity property, to replace this x bar y dot 1 is equal to x bar y. So you see that I am replacing this x bar y dot 1 as x complement y. So you see that this given expression has three terms. and it has total literals 8 literals, but now I have 2 terms and 4 literals. Okay, so this is a simplified form. Further you cannot go. Okay, further you cannot do anything because nothing is common here, so you will stop here. So this is my simplified expression. So directly you can implement this circuit, and you see that if you are reducing, so the required number of gates now is 1 2 3 4 5. So now you reduced, how many gates you reduced? Earlier you required 6 gates, and here you required 5 gates. So 1 gate you reduced here, 1 gate you reduced here. One more thing, you see that it requires a 3 input OR gate. Here you required only 2 input OR gate, so it will also affect in the speed. So this is the minimized circuit. Also you can write this expression as this expression is actually your x XOR y. So if you have XOR gate, so you can directly use XOR gate here. So this expression is your XOR gate, so you can directly use XOR gate. If XOR gate is available, so you can use a single XOR gate to implement this function. Okay. Something is wrong here. Anyone noticed?
Yes, ma'am. Z.
What I did wrong? I did wrong. So I explained everything, and no one is telling me that, madam, you wrote wrong expression.
X bar Z you took common, but
so I should write that x is var z. Okay. So this is the mistake here.
Yes, ma'am.
So I cannot implement this with the XOR. So the final expression is your x complement z plus x y complement. So that attentiveness I required here. Understand? So here, whatever I am showing you here, it is this x complement z plus x y complement. Circuit is correct, but expression I wrote here, it is wrong. Everyone noticed this?
Yes, ma'am.
So you should notice this, because whatever I am telling, I will not tell you every time a correct thing. So this is your duty to identify where I am telling you the wrong thing. So that will tell me that you are really hearing me or not. So only one girl responded, madam, you wrote wrong. So I am very happy with her. What is your name? Just tell me. Who responded me?
Pranati, ma'am.
Thanks, Bhagati. You pointed me a correct thing to me that I was expecting, that someone should tell me that I am explaining from one step to last step, and no one stopped me. So this is your duty. You should tell me, madam, you this step you wrote wrong. Got it? So this,
yes, ma'am.
This I will do again. Okay. So this is your duty. You should see and you should point out. So here, whatever I am showing you here, so expression, you see that I said in the first step, I said I am taking common x complement z, and I am removing the y by applying a law y plus y bar, and it is 1. So now finally you will get x complement z. So this is your final expression. So this is a correct expression, right? X complement z plus xy complement is the correct expression. And the implementation here I am showing, it is a correct. This implementation is correct. You see, x, this will generate x by complement, and this will generate x complement z, and finally you will get a sum of the x complement z and plus x y complement. So this circuit is correct. So you please note down. Everyone hope hearing me whatever I am telling you. So this is the simple. It is similar to the mathematics we already did in the algebra. So we are applying some laws and we are simplifying our given input expression. So you should always think from where you are starting. Here given thing is your Boolean expression. Now come to the second example. Now please note down and do it. This is the second example. Again you need to identify some common terms. So first step, as I said, first step, please look into the each term and see any term is common. If any term is common, means common, same. If any term is repeated here, you please write it once, then solve, then start solve. So no term is common here, so we can start minimizing. So everyone, please do it by yourself. If I am doing any mistake, you please notify me, because this is the thing that already you did. So only I need your attentiveness. So simplest thing I am telling you, but in the next slides I am going to tell you some complex things, some tricky things that you should know. So here I am writing the second step. I am taking common terms. So you see, in this term ABC complement is common, so I am taking common this term. Here in this, again, this is not common, so I am going to the another step. So here I found that ACD is common, so I am taking the common ACD term. Rest I am taking in the bracket, and then ACD bar B plus B bar. So see, so how many terms I am writing here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I am showing the term that is missing here. So you write here A, B, complement, C, D, complement. You add this term A, B complement, C, D complement. So from this I am taking common ACD complement. So these term I will remove. I will apply a law of, already I told you, x plus x bar is equal to 1. It is called complement property. So you will reduce. So every time you will reduce the term, but you cannot directly reduce. So you will show in the exam, you will show that 1 is coming. You are writing d plus d bar as a 1. You please show it. Don't write direct step, because each step you have to mention the theorem property. So you should write like this, and you should write at the in the right hand side, since as per complement property x plus x complement is equal to 1. That's why you are writing this step. Next step you will not directly write A B C, means directly you cannot write. So you will write A B C complement plus. Next step you are writing here. Here again you will write what property you are applying here. Again you are using, which property you are using? I am using this x dot 1 is equal to x. This property is called identity property. So you please don't jump directly from this step to this step. Okay, you please write this step, and you mention here that you are using this complement property. Here you mention you are using identity property, and then you further solve. Further you will take the common. So every time you are taking, you are writing the step, you please mention what property you are applying, because in the exam these things you it means while evaluation they will see whether you are applying, you are mentioning the theorems or not. Based on that they will give the marks. So if you want full marks, so please remember this thing. So here in this last step, we are using this property. What this property is called? X plus x complement y you can write as x plus y. So here you see that C and C complement here is present. So you can apply this theorem. So you will write B plus C. Okay. So this is called consensus theorem. Already I told you it is consensus theorem. So already we solved it. So directly you write the property result, and then A B complement C complement D you will write as it is. Now you will take A common, and then you will write. You see in all terms A is common, so you will take A common. Again you notice here that this term contains true signal B and it contains complement B. So again you can apply a consensus theorem. So what will be the consensus theorem? That means a variable B plus C complement D. Okay. So again you will take A common, and finally you will get A dot B plus C plus D. Everyone got it? Here 2 times we apply this same theorem. Here also we applied the consensus theorem. C plus C complement D is equal to C plus D. Okay. Here also we applied B plus B complement C complement D is equal to B plus C complement D. Okay. So these are the steps we use to simplify it. So you see that we started with the 7 terms and we reached up to the term that contains 4 literals. So any mistake I did here or any doubt here? So in the question this term was missing. You please write given equation 7 terms are there. So you please write this A B complement C D complement. Now come to the some problem that you may think that it is difficult and it is already a simplified form. So I am showing you some example that is tricky. So that requires is already we know that consensus theorem. It is also known as redundancy theorem. Okay. So first of all, we should know what is redundancy theorem. Actually, it is a very important term in the digital circuit, because if any redundant term is present in the expression, any redundant terms in the expression is present, it is not actually affecting the result, but it is actually affecting the hardware. Your number of gates is increasing, but if you see the role of the term in the output, it is actually, if you remove that term, it will not affect the output. So that term is called a redundant term. So generally this redundant term is actually not affecting the logic function when it is in the static state. See, if your inputs are continuously, if suppose high, it is continuously high or it is stable. If it is low, it is stable. But if suppose it is transiting from this point to this, if suppose it is changing state and you are observing the state of each input and you are trying to analyze the output at this time, when your signal is transiting and you want to trying to analyze the output, it will be difficult. So if suppose any redundant term is there, so it will affect it will not affect the output when it is in a static state. Means your input signal is stable. It is static. If it is static, then that term will not affect, that term will not play any role in the output. So here I am showing one example. So you see, this is the expression that you will find that it is it is already in a simplified form. Everyone, you please look into the special function. This is the tricky question. So what I am trying to tell you, that this term, if you get as a question, and you will see that you feel that it is already it is simplified. Everyone noticed? It seems that it is already simplified, but it is not. Why I am saying that? Because here, if you see that this term BC is not playing any role in the function. If you removed it, it will not affect in the function. You see here, if I will map it, so how mapping can be done, I will tell you later. But you try to, I'm trying to say what is common here, what is redundant here. So if I am mapping the A complement C here, so this will be this. If I am mapping the A B here, these are the one that will map 1 1. So you see that this one is common, and this one actually it is coming twice. So that BC is actually common in both terms. So if we will remove it, it will while we will remove, still your F will be same. So it will not affect in the function. So that redundant term, actually it seems it is useless, because if you will implement it, actually you required 3 number of AND gate. So you require 3 number of AND gate. If suppose you will remove this redundant term, you require only 2 number of AND gate. Okay. So if you are able to remove the redundant term, you can minimize the circuit. So how you can minimize the circuit? You will use a consensus theorem. That means your task will be to remove the redundant term. Redundant term are those terms that will not play any role in the function. So what are the disadvantage of the redundancy in the circuit is, if suppose you are unintentionally, if you are designing a circuit and redundancy is there, so this will result, means unintentional redundancy is there, so it will give you the poor design. So if unintentionally you are introducing redundancy in the circuit, it is a poor design practice. Okay, why I am saying, because while you will do some simulation, then you will realize this the importance of logical redundancy. Why it is very important? Because if you know that if any term is extra, additional, it will put burden in the logic circuit. So you don't want any extras, additional gates. Okay, so every time your task is to minimize the hardware. So why you will introduce any additional gate? No. So what you will try to do is, you will try to minimize the hardware. You will try to remove the redundant terms. So unintentionally, if you are doing that, this practice will be is actually poor. So you need to know what redundant terms are introduced unintentionally, and you should remove it. So what is the effect if any redundant term you are adding unnecessarily? It is actually increasing the network complexity. It is increasing the cost. Okay. Another thing is, it is actually adding means additional burden while testing. If suppose you are adding some redundant term, that means you need to give additional input pattern for testing the circuit. Okay, once you will design, next step is your to test the circuit. So if you are actually adding some redundant term, so it will affect in the ability to test the manufactured design using traditional test method. So your traditional test method may not identify the the defects in the circuit. Okay, so this will require additional efforts. Second, last is that testing, whatever testing you are doing. If you want to actually test the circuit, you need to apply this method that is called IDDQ models for testing the circuit. So these are the additional things you will learn later, but you understand why we want to remove the redundant term, what are the disadvantages. So you need to remember these 5 points. What is the advantage? Sometimes we intentionally introduce the redundant term. Sometimes we intentionally introduce redundant terms. So what is the advantage? Actually, as I said, redundant terms are useless when you are talking you are in the static state. But if you are in the transient state and some glitches are there, glitches means a short pulse. Short pulse, if suppose they are introducing in unintentionally, because at the time of transition, that glitches you want to suppress. If sometimes at the time of transition of various input signal, if glitches are present, you want to suppress. These glitches are actually unintentional fluctuation in the signal. So you want to suppress these glitches. So these glitches you can suppress by introducing a redundant circuit. So this type of other problem, if it is there, then you will use a redundant term. Also, it will help you to avoid the race condition. It will help in avoiding race condition. What is race condition? We will study later. But these 2 points is your advantage of the logic redundancy. So if any term is containing any means, you should notice where you are going to apply the redundancy theorem. You should understand. So there are some ways to identify consciousness theorem or redundancy theorem is required or not. So as I said, this is the example. A B plus A complement C plus BC, if suppose it is a given Boolean expression. So what you need to check? So you will check some condition. What I am telling you that if any expression is given and you want to see whether consciousness theorem is required or not, how to identify? How to identify? You need to apply a consciousness theorem. So what are the things you will notice? So these 4 points I am showing you here to identify whether consciousness theorem is you need to apply or not. So first you will check whether in all term all variables are present or not. So you will check whether all terms means in the expression all ABC, if F is the ABC dependent, you will identify that total ABC terms are here or not. So here all variables are present. Second thing you will notice, each variable should repeat twice. So each variable is repeated twice or not. So you see that B is repeated twice, C is also repeated twice, and one variable must be present in complemented form. All variable must repeat twice. Only one variable must be present in complemented form. So see here, A is present here and A complement is present here. So these 3 things you will check in the expression. All variable must present, each variable should repeat twice, and one of the variable must have in a complemented form. So 3 things you will notice. Okay, and then if you want to simplify this expression, what will you do? So this is the 4th step written here. For reduction, you will consider the term containing the variable which has been complemented. So for reduction, you will consider this term, A complement C term. So you see that. So actually what redundant terms here is, so you see that the term, the variable that is in a true form and its complementary form, that will present, and rest term will be redundant. So here your a is present here, a is present here, a complement is present here. So this is the complemented form is present. So these two terms are relevant, and this term is redundant. This term is redundant. So I will show you how this term is redundant. It will automatically removed while simplified. So you will notice that f will equal to ab plus a complement c, and bc will remove. So you will identify that if suppose I am taking this expression, and if I am taking expression that does not contains bc, it is same. So you will identify this bc is the redundant term. So three things I noticed here: all abc is present, and all term each variable is repeated twice, and one variable a is present in a complemented form. So the term which we are going to remove it is called redundance. So this bc is actually the term which is omitted. It is called consensus of the other two terms. It is called redundant term, or it is also known as consensus of the other two terms. So how I will simplify? So I will start with the f equal to ab, a complement c plus bc. So you see how to solve this question. It seems that it is already in a simplified form, but not. It is not in a simplified form. I will show you how to simplify it. So here you notice that it is the problem that you need to apply consensus theorem. How you identify? You identify that all variables are present. Each variable is repeated twice, and one variable is in a complemented form. So three things you notice here, and then what will you see? So the variable that is in a complemented form, you will write as it is, and the term that is not containing a, I will use this theorem. A dot 1 equals to a. So I know that bc dot 1 is actually bc, so it will not affect the equation. Then you will replace this one with the a plus, that you will replace this one with the variable that is not present here. So a is not present, so I am using a property a plus a complement equals to 1. Now I will expand. So this is a tricky question. You please look here carefully. So just I multiplied inside. So what is actually called? It is called distributive law. I'm using distributive law. Now I will write this term and this term, because AB is common in both terms. Here A complement C is common. Then I will take common AB. So it is 1 plus C. Here your A complement C is common. You will write here. And you know that the law 1 plus A is equal to 1. So AB dot 1 plus A complement C dot 1. Again you will apply the rule A dot 1 is equal to A. So every time you please write the law. Identity law, idempotent law, complement law, whatever I am writing here, you please write it. And then last step is A, B, A complement C. So this is the final expression, you see it is in a simplified form, and you identify that we started from here, and you now compare this expression and the final expression. So what you noticed here, I started from here and I reached here. You identify AB is here, AB is here. A complement C is here, A complement C is here. But BC is not present in my final expression. So what you understand? That this BC term is actually your redundant term. Because it shows you that if BC is present and if BC is not present, it is not affecting my output. Okay. So what is the conclusion? BC is my redundant term. The presence of BC is not affecting the F. Okay. So we can remove it. So what is the important thing here is that actually you minimize the hardware. One term you already removed, that means your hardware is minimized. Any doubt? See, this is a tricky question. You may confuse if suppose you will see the thing directly. That's why I'm saying this is an important expression. You required to understand how to solve it. So I told you the method, how to identify. You need to take into account some 3 steps I told you. So you first see if suppose you found that this is already in a simplified form. So please check it. So everyone got it? What I explained you here? Anything wrong?
No, ma'am.
Okay, so I hope you understand. So one more example I am taking here. It is again related to this theorem. Just you please identify what I said to you. See here. So these are the tricky questions. See, you may confuse in the exam. That's why I am telling you, please take care of this thing. You please see. This is I am showing you the example of the POS form. So what is the trick I said to you? So you see that you will find that it is already in a simplified form. What is there to simplify? You notice? Nothing is common. So it seems that it is already in a simplified state. So please, before saying this, you need to identify whether it is in a simplified form or not. So I told you the first step I said, you need to check whether all variables are there. So in the expression A, B, C are there, okay. Second, I said you need to see whether each variable are repeated twice. Yes, it is repeated twice. B is repeated, C is repeated, A is also repeated. Okay, so all variables are repeated twice. Third check I said, any means one variable is in a true form and it in its complement form. Yes, it is here. A is there. So A is in the complement form. So that means it can be further simplified by applying the consensus theorem. So this is the trick. You have to check it. So 3 checks I told you. 3 checks I told you. First, you will see all variables are present. Second, you will see that each variables are repeating twice. Third, you will see that one variable is in a complemented form or not. So 3 checks you need to do before saying that it is already in a simplified form. What is there to simplify here? Got it? So what will you do here? So prove it that it is not in a simplified form. So what is the trick you will do for the POS form? For SOP form, I already told you. What will you do? For POS form, what will you do? You will retain the term that contains a true variable and its complement form. So trick, you please see how to reduce. You will retain the term as it is that contains the variable that is in the complemented form. As it is, I am noting here. You are retaining the term that contains A and its complement. See? So the important thing, what will you do here? You need to see this term only, B plus C. So what will you do? V plus C, you will add 0. So you are actually applying the theorem. X plus 0 is equal to x. That theorem I am using here. Further, so one example I took for SOP form, another example I am taking for POS form. So you please look it carefully, then I will give you one more problem. And then you will replace this 0 with what? A, that variable that is missing here, you will use A, and you already know that A dot A complement is 0. Okay, so that property I am using here to introduce the missing variable. So here the beauty is you are not actually taking common here. Actually, you are first expanding and then you are absorbing. So you see that, as I said, the theorem x bar plus y. That theorem I already told you. That theorem, what it is called? Can anyone tell me what it is called? Or shall I write again? Otherwise you will confuse here. This theorem I already told you. Right? So this theorem I will use here to expand this. So this I am assuming it is x, and this I am assuming y, this I am assuming z. So this theorem I am applying here. So what it says, if x plus y z, then you can write it as x plus y, x plus z. So x is my ab plus c, y is my a, x is my b plus c, and z is my a bar. So that term, you will simplify it. You will divide into two separate terms. What it says? It is called, what this theorem is called? X plus y z equal to x plus y into x plus z. It is called distributive law. So here I am using a distributive law. Now further, what will you do? So you see there, here A plus B, here A plus B. So you will write in one side. Here you are identify A bar plus C. Here A bar plus C. You will write here in one side. Now further, what will you do? Now you will apply, which theorem you will apply? Which theorem you will apply? Just to identify, I am writing here. Since x into x plus y is equal to what it is? X. Okay, I told you the law of property. What I told you? X into x plus y is equal to x. That is called absorption law. So you please go through the table. So you will remember that I am applying absorption property to reduce the term. So you identify, for example, I am saying a plus b is my x, a plus b is my x, and c is my y. So you apply this. So this is x into x plus y. Okay, so this thing you can apply here. So I will write here is a plus b only. Okay, y will my wash out. Now see here, again I assume this is my a complement plus c is x, a complement c is x, and b I am assuming y. So again you can apply this theorem. Again it is saying x dot x plus y. So I can write it as x. What is x here? A complement plus c. So this is my final expression, simplified expression, and you compare. So you will once you will see that we started with this expression, and it contains a plus b. It also contained a plus b. You notice here. It also contains a complement plus c. It is also contained a complement plus c. But in the final step, d plus c is nowhere. So what you found, that this d plus c term is your redundant term. Whether it is present and it is not present, it is not affecting your f. So you see the simplified form, it requires 2 number of OR gates and it will require 3 number of OR gates. So now it is a simplified form. So I hope everyone got it what I said. So if you got it, then I am giving one problem you solve and just help me to solve. Note down please. D complement plus F, E complement plus F complement, D complement plus E complement. Okay, solve it. So everyone, you solve it and tell me the final result. So this is the problem related to the redundancy. So I will check it whether it is related to redundancy or not. So what I said, you will check whether all variables are there. So you see that your f is function of d, e and f. Okay. So 3 variables are there. So identify d, e and f are there in the expression. Yes. Second thing, I said that each variables are repeated twice. Yes. E complement, E complement, D complement, D complement, F and F complement. So all terms are repeated. Third thing, any variable is in complement form. Yes, F is in a complement form. So all checks are fulfilled here. So it is saying to me that this expression contains one redundant term. So we need to remove the redundant term, but I am saying you cannot directly remove the redundant term. Already we noticed here. Which term is redundant here? Anyone please tell me? Which term is redundant here? Anyone notice? If you understand what I am trying to say. Anyone tell me the final.
D bar plus E bar.
Good, very good.
D bar plus E bar.
Good, very good. You notice na? The term that contains a true form and complement form, that you will retain, and that term that does not contain that variable, it is called my redundant term. So directly you can say the answer is D complement plus F. So this will help you to attempt the GATE exam. If you know the trick, you can directly tell the answer, this is the answer. So how this is the answer? You know the answer is that it contains a redundant term, so we can remove it. Got it? So how you will come out with this answer? If I am asking you to do the justify it, how you are getting this answer? So how will you solve? How will you solve? Just solve it. Solve it, everyone. One minute is there, so just do fast, solve it. Then I will leave. And for homework, I am writing. Just please note down one problem as a homework, because one you are doing here, and another problem you please do it at your home. So this is a problem I am giving you for homework, and it is in a SOP form. You please solve it. Same thing you need to repeat. It is related to redundancy problem. So just you need to do it at your home. So this D plus F, this problem we will solve here first. So this is our problem. So what we will do? As I notice that this F is actually in a complemented form, so I will take this term for treatment. So what I will do? I will apply a theorem that any variable, if suppose x and its complement is equal to 0, sorry, what I said, sorry, x plus 0 is equal to 0. So that property I am using here, and further I am applying next step is I am replacing the 0 with the f complement. Now I am applying this theorem. Now I will use which theorem I used here? Which theorem I used here? Please help me. X plus yz. This is distributive law I used here. So this distributive law I will use here to expand. So d bar plus e bar plus f, d bar plus e bar plus f bar. So this is the distributive law I applied here, and then I will take the terms that are same in one side. So I am taking this term here. I am taking this term here. E bar plus f bar plus d bar. I am writing like this so that you can identify the form x plus y is equal to x. So I am applying here absorption theorem. So this is d bar plus f, and this is your e bar plus f. So you have to write this. How you are writing this step and then this step, you need to mention this. These things are very important, please. You don't forget to write these laws, because even though your answer is correct, but you may lose marks. So these theorem you have to mention why you are writing this step and then this step. So you need to mention the law. So this is the final answer. So this is these were the questions that are related to actually means you can see these tricky questions in the GATE exams. So if time is very less and you are able to identify the shortcut, you can apply. So it will be easy for you to get the good score. So this is all for today. So you please practice some questions related to the minimization of Boolean expression. So I hope I will give you some problems for the practice. So please do it and have confidence. And tomorrow we are going to discuss. I'm going to discuss about the K-map. So you please do this, complete this method today, and then come out with the another method K-map tomorrow. So this will be very interesting topic. So I hope you will like it. Okay, thank you for today.